Okay, dear students, so welcome to this second video of this series now. So we were talking about the Thomson model that came into in what year? I think 1904. Thomson was the person who gave his model. Later in 1911, Rutherford came into picture. Now everybody was saying that yeah, Rutherford is an intelligent guy. He created a very beautiful theory. Astounding, isn't it? So he got his name written in the golden letters. But very soon, just after 2 years, Bohr came into picture. And Bohr said, no, I will see through it. I will see through it. So what Bohr did was he did one experiment, a very simple experiment, but still changed the physics forever. He said that let's say the white light was coming and there is this prism here. Well, this experiment, this is known as dispersion, which was first done by way back by Newton, 1675. But this is not in your syllabus properly. So this white light is coming here, but we just know this that it is now getting separated into seven colors, and these colors have been projected onto the screen, so you are getting actually this kind of a colorful pattern here, which starts with violet and it goes to red. So Vibgyor, like here in India we call it Vibgyor, but in many countries it is known as Roy G Biv. So don't worry, you can call it Roy G Biv or you call it Vibgyor, one is the same thing. So this pattern was supposed to be coming on the screen, but he found very interesting phenomena. He said that yes, this is coming out to be very colorful pattern here, but if I place a cylinder here, or you can say a capsule which is containing some gas, hydrogen gas, oxygen, nitrogen, anything for that sake, he took hydrogen and he said that white light is first passing through the hydrogen and going to the prism. So this spectrum is creating a difference. Now, what is the difference that is coming in the spectrum? This spectrum is now having these black intermittent lines, and you don't know why they are occurring there. So he was not able to answer that, like what is happening there. This is known as hydrogen absorption spectrum. Why? Because white light, which is having all the colors, all the frequencies, all the wavelengths, it is going into the hydrogen, and after that some colors have been absorbed by hydrogen, and now other colors are being shown here in the spectrum, but there are some black lines coming in between. This is known as hydrogen absorption spectrum. Now, there is another spectrum which is called hydrogen emission spectrum. Now, what is this? If we put off this light now, like there is no light which is coming from outside, what happens is this hydrogen, which has absorbed these colors earlier, it starts emitting that light again, and all those frequencies and wavelengths which were earlier absorbed, they are now becoming visible with a uh, black background, because actually the light is not there. So you are getting only the light which was earlier absorbed by hydrogen. In this case, hydrogen is taking up some colors and creating black lines, and in this case hydrogen is giving up those colors back again. It is emitting those things. So there is a black background but some colored lines on the black background. This is called emission spectrum. Now, the problem came when the same question was posed to Rutherford, that why is this happening? And Rutherford was not able to answer it. Like there is no answer for this. So first of all, the Bohr's experiment posed a very considerable big challenge to Rutherford's theory, and that is why his theory came under questions. Another very big question that was not answered by Rutherford was, in 1862, Maxwell has given a theory about electromagnetic wave, and he says that accelerated charges, they emit electromagnetic waves. It means that if, let's say, this is the nucleus and one electron is moving around in the circle, which is actually an accelerated motion, centripetal acceleration. So when electron is moving in a circular fashion, there is centripetal acceleration taking place. So it is an accelerated motion. So accelerated motion is going to emit some energy. This is electromagnetic wave. So if it is emitting some energy, it is losing energy. Now, because it is losing energy, the radius should keep on decreasing with time, and with time, it will fall into the nucleus. Now, Maxwell theory came way back in 1862, which established that light is actually electromagnetic wave, which is moving with the speed of light at 3 into 10 raised to power 8 meter per second. So it was very difficult to say that Maxwell was wrong. So Maxwell was indeed not wrong. So Rutherford's theory had a second big threat now. So the first threat came from Bohr, the second was from the Maxwell, and Rutherford's model failed to explain these two theories. It is a straightforward question to Rutherford: why the electron, which is moving just like a planet in the atom, why is it not losing the energy, and why it is not falling into the nucleus? Now, having said that, so the Rutherford model was rejected, and they said that okay, some new model has to be created, and Bohr came with that new model. So that we will see in our next video, like what are the Bohr's postulate and what is an atom looking like with respect to Bohr's theory, which came in 1913. Okay, dear students, thanks for watching the video. This is Professor Varun. Bye.